Before we go any further, if you value serious historical analysis applied to real-world survival thinking, subscribe to this channel and share it with someone who still believes history is only about dates and uniforms. What we are covering today is not nostalgia. It is usable knowledge. During the Second World War, millions of civilians survived sustained bombing campaigns not because of luck, but because of deliberate underground design. Those shelters were engineered under pressure, tested by fire, and refined through loss. If you understand how they worked, you can adapt the same principles to modern threats ranging from infrastructure collapse to long-duration urban unrest. This opening matters because at WWII civilian shelters were not theoretical. In cities like London, people lived underground for months at a time during the Blitz, not in comfort, but in survivable conditions. The reason most modern panic rooms fail is that they focus on short-term fear scenarios. WWII bunkers were built for endurance. That difference is where the lessons begin. Why civilian bunkers were built differently from military fortifications. Military bunkers were designed to hold ground. Civilian shelters were designed to preserve life under repeated stress. That distinction shaped everything from depth to ventilation. In Britain and Germany, most civilian shelters were shallow enough to be built quickly, but reinforced to absorb shock waves rather than resist direct penetration. Walls flexed slightly instead of cracking. Ceilings were arched or ribbed to deflect blast pressure downward. Now, this is really critical today because, many people assume thicker concrete is always better. But WWII engineers learned that shock absorption mattered more than just raw mass. If you are adapting a basement or underground room today, the practical application is actually quite simple. Reinforce walls with layered materials that dissipate energy, such as concrete combined with compacted earth and internal framing, instead of just relying on a single rigid barrier. WWII. Hotels survived because, they bent before they broke. How ventilation kept people alive when oxygen became the real enemy. One of the least discussed aspects of WWII shelters is, in fact, air management. Bombing collapsed streets, sealed entrances and trapped people underground for days. Carbon dioxide buildup, not explosives, became the silent killer. Civilian bunkers used passive airflow systems with vertical shafts, baffles and manual airflow control. Some London shelters used staggered vents that prevented blast pressure from travelling directly inside while still allowing air exchange. Applied today, this means never relying solely on powered ventilation. A modern shelter should have at least 2 passive airflow paths positioned at different heights, with the ability to close or restrict them manually. WWII shelter managers rotated occupancy zones to prevent localized oxygen depletion. What sanitation solutions reveal about long-term confinement? Civilian shelters failed fastest when waste management was ignored. WWII shelters used dry latrine systems with layered absorbent materials, often sand or ash, and strict disposal routines. This was not optional. Disease spread faster underground than above ground. Shelter wardens enforced cleaning schedules because survival depended on it. For modern adaptation, the lesson is discipline, not technology. A chemical toilet is useful, but only if it is supported by cleaning protocols and separation from living areas. WWII shelters designated sanitation zones downwind of airflow whenever possible. In a modern context, placing waste systems near exhaust vents reduces contamination risk. This is not comfort planning, it is survival planning. How psychological endurance was engineered, not left to chance. W2 shelters accounted for morale in ways most modern designs ignore. Lighting was dim but consistent to preserve circadian rhythm. Noise control mattered because constant vibration led to panic and exhaustion. Shelter layouts avoided long, narrow corridors that amplified sound and fear. These were learned adaptations after early failures. Today, this translates into designing underground spaces with visual separation, stable lighting cycles, and sound-dampening materials. Even during short-term sheltering, psychological degradation leads to poor decisions. WWII planners learned this the hard way, and their solutions remain relevant. So, what do the contrasts between German and British shelters actually teach us about adaptability? Well, German civilian bunkers were, often much deeper and more rigid in their construction, while British shelters tended to prioritise speed and decentralisation. When German cities faced those sustained bombings, the deep shelters sometimes turned into, sadly, mass casualty sites if the entrances collapsed. On the other hand, the British approach, those distributed shelters, really reduced the risk of single-point failures. This contrast, I think, offers a pretty clear modern takeaway. It's best to avoid centralised underground spaces that depend on just one access route. If you're adapting a modern structure, it's wise to, prioritise multiple exits and keep things at a shallower depth while also using lateral reinforcement. The Second World War really demonstrated that survivability increases when escape options remain viable, even after a partial collapse. Now, let's talk about how we can apply those WWII shelter principles to the risks we face in our modern urban environments. First, start by identifying an underground or semi-underground space that already exists. It's often better to reinforce these spaces rather than excavate new ones, when possible. Consider adding layered wall reinforcement, passive ventilation, and strict zoning for sanitation and rest. These steps can make a significant difference, When it comes to stocking supplies, aim for endurance rather than comfort. Focus on essentials like water, airflow control, and hygiene tools. You see, WWII shelters weren't filled with luxuries. They were stocked with what kept people alive on day 10, not just day 1. It's quite a practical approach, don't you think? This is precisely why WWII civilian shelters remain relevant even today. They were born out of necessity, refined by failure, and proven under sustained attack. While modern threats might look different, the fundamentals of human physiology and structural physics haven't changed. It's fascinating how some things just stay the same, isn't it? If this kind of historically grounded survival analysis resonates with you, why not subscribe to the channel? Share this video with someone who might still underestimate civilian resilience, and stay tuned for more. History has already solved more problems than we are willing to admit after all.